solving this question, 2 raised to the power square root of u equals to square root of 32 raised to the power of u. What we need to observe here is that the unknown variable we're looking for is at both sides of the equation. And the best thing to do in order to handle this is to make sure that the both sides of the equation have equal base. We have 2 here as the base, then we have square root of 32 here as the base. We're just going to need to convert them to the same thing. Therefore, we say 2 raised to the power of u equals to 32 raised to the power of half. Put this in parentheses, then the u power is still there. We have this exponent of half there simply because if we have a, that is the square root of a, it's just the same thing as if we say a raised to the power of half, and that actually explains the exponent of half that we have here. To continue with this campaign, we're going to rewrite 32 2 raised to the power of 5, and of course this is where I'm going to continue using here. Instead of writing 32, I'm going to use 2 raised to the power of 5. Therefore, my equation can be written as this: 2 raised to the power of square root of u equals to, then I have 2 raised to the power of 5, then put this in parentheses, then this half is still here, then we have this u that is still there outside. Following an index rule that if we have a raised to the power of n in parentheses, then we have the whole stuff raised to the power of n, and this is going to result into a raised to the power of n multiplied by n. Therefore, doing the same thing here, we have 2 raised to the power of square root of u equals to 2 raised to the power of 5, then multiply by 1 over 2, then multiply by u here. At the end of the day here, we multiply this, the numerator all through, then this is fraction. We make this appear as fraction also, and also u over 1, and this 5 multiplied by this 1 multiplied by this u, that's going to be 5u at the level of numerator there. Then at the level of denominator, I have 1 multiplied by 2 multiplied by 1, that is 5u over 2. So I can rewrite and say 2 now is raised to the power of 5u over 2. At the end of the day, I still have 2 raised to the power of square root of u equals to 2 raised to the power of 5u over 2. And this is where actually I'm going to need an index rule that says whenever I have a raised to the power of n and at the same time equal to the same base a raised to the power of n, therefore n is just going to be equal to n. That is this one go, this one go. And the same thing is what I'm going to apply to this my equation at this left hand side here. I have the same base, that is just the requirement. Then the next thing is that this one go and this one go. So what do I have left? I have square root of u equals to 5u over 2. And what am I going to do next? I'm still looking what the value of u is going to be, and I'm still having the same u at both sides of the equation. So I wish one of the u's just disappear, then I say my u equals to certain number. So what am I going to do to achieve that? So what if I square both sides? At least it's going to solve this problem of square root here. This rule says if I have a square root and it's just the same thing as a raised to the power of half, so definitely if I square this side is going to cancel the power, and at the same time if I square this side, it's going to cancel the roots. So that's what I'm going to apply here, except that I must apply the power to both sides of the equation. Therefore, I can say square root of u all square equals to 5u over 2 all square at the same time. Also, according to the explanation above here, this is going to cancel this square root. And don't forget, what we have here is just the same thing as if we say 5 over 2, then we have u here, the whole stuff raised to the power of 2, because I'm gonna need this an index rule knowledge here, which says if I have a then multiplied by p in parentheses all square, it's just the same thing. I can also write it as a square multiplied by b square. Therefore, my equation will become, I only have u here, that is what is left here. And don't forget, if I apply this rule into this right hand side of what I have left, I'm gonna have 5 over 2 all square multiplied by u square. Also, the twin brother of this index rule is what I'm going to need to apply to this part of the equation, which says whenever I have a over b all in parentheses raised to the power of 2, it can be written as a raised to the power of 2 then b raised to the power of 2. What are we saying in essence is that this 2 is going to affect this 5, and at the same time this 2 is going to affect this denominator. Therefore, we have u equals to 5 raised by the power of 2, that is 5 square, then 2 square, then multiplied by u square. At the end of the day here, we have u equals to 25 over 4 and multiplied by u square. So we can easily say, okay, this is fraction, making this appearing as fraction. Also 25 times u squared, that is 25 u squared, then 4 times 1, that is 4. So we have 25 u squared over 4. So from this point on, we can easily say, okay, this is fraction, or u also appear as fraction. Then we can cross multiply here, that is this go for this and this go for this. Therefore, we're gonna have 25 u squared equals to, that is 4 times u, that's gonna be 4u. Then bringing this one to left hand side, we have 25 u squared minus 4u equals to 0. Even without a thorough checking, you can see that I have u present here and I have the same u present here. What if I bring out the common terms by factorizing? Then this is going to become u into 25u minus 4, then close this, and this is going to be equal to 0. Then if we multiply two things and we get 0, so that shows that it's either the first one is equal to 0 or the second one equals to 0. That is u equals to 0 or 25u minus 4 equals to 0. From this, we're gonna have 25u equals to 4 by subtracting 4 from both sides, and at the same time by dividing both sides by 25. So what do we have left? These go for this, and we have u equals to 4 over 25. Now this is our final answer. U is equal to 0, and at the same time u equals to 4 over 25. Final answer. And just before we go, we're going to need to confirm if these values are actually correct by substituting the value of u that we get here, that is 0, into position of u here. Then at the end of the day, we're going to confirm if the left hand side is equal to the right hand side. Then we're going to do the same thing for the second value of u. Hence, to do this, confirming if u equals to 0. If I insert that properly, I'm going to have 2 into the square root of 0. This time around is going to be 0 now, because u is to be tested. If it is 0, then equals to, that is, square root of 32, then raised to the power of 0. So to the left hand side, square root of 0 is just 0, so we have 2 raised to the power of 0 equals to, in my memories, any number, anything raised to the power of 0, of course, is going to be 1. So we have 1 here, and at the same time, that's what we have here. 2 raised to the power of 0 is 1, and it just equals to 1. Therefore, for the left hand side to be equal to the right hand side, that shows that the value of u to be 0 is actually correct. So to confirm the second one, if u is actually equal to 4 over 25. So doing the same thing as the previous one, we're going to have 2 raised to the power of 4 over 25. Everything under square root equals to square root of 32 raised to the power of 4 over 25. Looking at this, according to solve, this is going to split. So we have 2 raised to the power of square root of 4 over square root of 25. And here also, this square root is just the same thing as power of half. So we have 32 raised to the power of half. Put this in parentheses, then the former power, which is 4 over 25, is still there. Now we say from here, the square root of 4 is 2. The square root of 25 is 5. Considering the positive value, we now have 2 raised to the power of 2 over 5. Then we're going to multiply this according to index rule. 2 goes here 1, 2 goes here 2. At the end of the day, we have 32 just equal to 32 to the power of 2 over 35. And the next thing we're going to do, we're going to rewrite this 32 in form of index. We now have 2 raised to the power of 2 over 5, and this equals to 2 raised to the power of 5. Put this in parentheses, then we still have 2 over 25. According to an index, we're going to multiply this power. So 5 goes there, that is 1, 5 goes there, that is 5. So what we have left now is just 1 multiplied by 2, that is 2, then 1 multiplied by 5, that is 5. So we have 2 raised to the power of 2 over 5 at the right hand side. That is 2 to the power of 2 over 5 equals to, we have 2 here, the same place there, we have 2 over 5 left. So 2 raised to the power of 2 over 5 just equal to 2 raised to the power of 2 over 5. And this has also proved and shown that this value, that u is equal to 4 over 25, is also correct. And just before you go,